Hey there, Cal class. So okay, granted, yes, you're right. I did not take care of personal hygiene like I usually do. You don't have to comment on it, okay? Um, so look, I left off kind of in midstream in your notes. So you should get your notes out because I want you to have an example in there of how to do the first derivative test, okay? So pause the video, get your notes. Okay, so you should remember this. Let's just review. One of the big reasons to use derivatives is because they help you find the maxes and mins of a function. And there's kind of two steps to that. The first one is you got to get all the what I call the candidates, the all the points that might be maxes and mins. Those are called critical points, and you can find those critical points by setting f prime equal to 0 or seeing where it doesn't exist. And that'll give you your whole big batch of possible extreme, okay, all the candidates. Next thing you do, that's the first step, the next thing you do is you run them all through the first derivative test. And the first derivative test will sort out which of those critical points are maxes, which are mins, and which are fakeouts, okay? So that's all put in your notes. I also said you should use some mysterious thing called a sign chart to help you organize your findings. So that's what I wanted to show you, but we ran out of time last time, okay? So let me do an example. Again, you want to put this in your notes. I think that's a good idea, okay? So here's my example. Let's say we have y equals x cubed minus 27x and then minus 20. Bam, okay? X cubed. Hopefully the camera's turning that around because right now it looks backwards to me. So if I want the maxes or mins, let's do my first step. I need to find the critical points, right? So I'm going to set the derivative. Well, first let me take the derivative. Equals 3x squared minus 27. Okay. I set that derivative equal to 0, and I also find where it doesn't exist. Now, I just got to tell you this. Any polynomial like this, the derivative is always going to exist. Polynomials are just well-behaved functions. They never scoot off to infinity or have weird discontinuity. So just look, I mean, this is a parabola. Wait. Yeah, this is a parabola, right? So it's going to exist everywhere. So we only have to think about where it equals 0. Okay, let's do that. Hop on the factor tractor. X squared minus 9. And then that's going to be x plus 3, x minus 3, bam, right? So can you see where this equals 0? So either x equals negative 3 or x equals 3. And I'm going to label those. And you don't have to, but I think it's kind of good to keep your thinking organized. I have found my critical points. This is the basket. Now I got to go through the second step. Run all of them through the first derivative test, which will sort them out into maxes, mins, and fakeouts, okay? So I do that using this thing called a sign chart. All it is a number line, okay? Just a number line. So when I do my sign chart, I make a number line, Shazam, and I label it. It's important to label this because, as y prime, is what will be, because that's not the only sign chart we'll ever use. Sometimes we'll do them for y double prime, okay? That's later, though. So label this as y prime, your sign chart, and then just put your critical points on it. And they don't need to be to scale or anything like that. I just usually, no, that's fine. That's the only thing I'm going to do, okay? Now, the reason this helps me organize my findings, this sign chart, is because I can now figure out where the function is increasing and decreasing. Because I know the derivative is 0 here and here, right? In fact, here, let me just put that in there. That's a good idea. I'm going to put a 0 right here because y prime was 0 at negative 3, right? That's how we just figured that previous thing out. And then it's 0 right here, okay? So then what I do is I just pick numbers on either side of the critical points to see what the sign of f prime is, whether f prime is positive or negative. So let me give you an example. What's a nice easy number between negative 3 and positive 3? Say 0. Yes, that's a great one, 0. So let's just put 0 in. Do you agree Here, this is like probably the easiest one. This is my first derivative, right? So let's just put 0 in here. Do you agree we get a positive times a negative then? So then that's negative, right? So it must be the case that everywhere between -3 and +3, the f prime is negative. Y prime is negative. So I'm just going to put a little negative sign there, okay? Then I'm going to do it for this region and this region also. So let's do the positive one first because that's easier. And a lot of times, like, I just plug in some obnoxiously big number to make the arithmetic easy because I don't actually care about the value of y prime. I'm only looking to see what is its sign, positive or negative. So plug in, I don't care, like 1,000. If you do 1,000 squared minus 9, it's definitely positive. Times a 3, definitely positive. So I would put a little plus sign over here, okay? And then what's a nice, well, shouldn't say a nice easy number. Let's do an obnoxiously large number that's past -3. So let's say -1,000, okay? So if you square -1,000, guess what? That's a positive, right? Positive, gigantic positive minus 9 times 3. Can you tell that this is going to be positive? So I'm going to put a positive right there. And now I can just look at this and know where the max and the min are. Y prime is positive here. That means y must be increasing, right? And then you don't have to put this little arc in your notes here. I just thought it might be helpful for you to visualize. And then right at -3, y prime is 0. So that means this guy must have a horizontal tangent line right at, I wonder if I can, right at -3. And then y prime is negative. So that means y must be decreasing now, right? And then by the time it gets to 3, it's y prime is 0. So that means y must have a horizontal tangent line again. And then after 3, y prime is positive. So guess what y is doing? Increasing. Do you see why that poster is so useful? Like, you just got to know it. Anyway, can you tell where your max and min are now? I can just look at this and know that, oh, look, positive to negative. This is going to be my max, and this is going to be my min. Shazam, done, you know. And there are no fake outs in this one. So for about 90% of the problems that might appear on my quizzes or the AP tests, you're basically done. Go ahead and you don't, like I said, you don't have to put this in here. Once you become an expert at this stuff, you never would even do that. You would just look up here and say, oh, I know where my min and my max are. But it's probably courteous to really end this and say, okay, min at 3, max at, and I suppose there should x equals 3, and max at x equals -3. Shazam, those are your answers. And like I was about to say, 90% of the time, that's all you need. Give me the max, give me the min, move on to the next problem. There are times on the AP test, and so there are times in my quizzes also, just to prepare you. In the free response part of the AP test, they will say, justify your answers there. And so I don't know if you can hear that. All right, we just put our youngest kid to bed, and she's not tired. Anyway, they'll ask you to justify your answer, and all it takes is one sentence. Okay, all you got to do is write something like this: there is a min. Let's go with a min at x equals 3 because y prime goes from negative to positive there. Okay, can you read that, hopefully? There's a min at x equals 3. I hope it's 3, right? Yeah. Because y prime goes from positive to negative there. You write that, and that they will consider that justified. You have explained why you think there's a min. Great, okay? And you could do the same thing for the max if they asked for that. Okay, this video is really long. I just want to say one other thing that you will find very useful. You're going to be doing this a bunch from here on in, okay, up through like maybe January. up through January where we switched focuses a little bit, you'll be taking the derivative, setting equal to 0, or taking going to the second derivative and setting that equal to 0. There's going to be a whole bunch of derivative taking and then algebraic solving. So I just want to give you another hint, and I think you should put this in your notes, okay? The last thing is, so I just want to say general calculus tip. I guess, yeah, this kind of goes for everything that we'll be doing. So general calculus tip. Okay, general calculus tip. Here it is. When taking derivatives, okay, sorry, my finger's getting in the way. When taking derivatives, collapse fractions, that makes things easier. Collapse fractions and put everything in jeepers creepers, in exponential notation, okay? Because then you can use the power rule. You don't have to do the quotient rule hopefully you don't have to. So that's really nice, to collapse the fractions and put everything in exponential notation, and then that usually makes derivative taking easier. Then, once you have the derivative, like once you get to this step here, and you have to set it equal to 0 and then solve, then just undo all that. So I'm going to write, when solving equations, when you're doing the algebra part, in other words, uncollapsed fractions, and often radical notation is easier to understand. I'll put that in there. These are all guidelines, not hard and fast rules, okay? And so when solving uncollapsed fractions and use radical notation. Radical notation. Okay? So I am done. Now you just need a lot of practice going from f to f prime and understanding what f prime is telling you about f and using the first derivative test and finding critical points. So the stuff I'm about to sign in the old textbook is really good for that. Please take it seriously and check your answers in the back. Noah, see ya.